Today we're going to do a revision of everything we've been doing over the last few weeks. So metals and extraction of metals and the different ways that you can extract metals. I'm going to go through a few things on paper just to refresh your memories, and then I'm going to give you some questions to do. Pretty much all of the answers to the questions are going to be in this video. So when it comes to the questions, if you get stuck, just replay this video. Okay, so we're going to start with metals themselves. On our periodic table, you see that the metals are all these guys here that are on the left of this line. So most of the periodic table you will see are actually metals. And even though you might normally associate them just with chemistry and with, in a lab, they do all occur naturally. Okay, sodium occurs naturally, manganese occurs naturally, iron occurs naturally. They're not things that you make in the lab. They are things that occur naturally. And if you wanted to go looking for metals, you would go and look in the Earth's crust. That's where you're going to find metals, in the Earth's crust. But most metals are reactive, and because they're reactive, you will not find them as pure metals. And when metals react, they all do exactly the same thing. Metals are reactive, they will all lose electrons, okay? All metals, every single time they react, they always lose electrons. They're never going to gain electrons. If you want to know how many electrons they'll lose, you just look at what group they're in. So if you're in group 1, you will lose 1 electron. If you're in group 2, you will lose 2 electrons. If you're a group 3 metal, you will lose 3 electrons. In terms of all these metals in here, it gets a little bit more complicated because the number of electrons they lose changes. But you don't need to know how many electrons they're going to lose unless they're in group 1, 2, or 3. Because they're all losing electrons, they all form positive ions. Remember, an ion is an atom that has lost or gained an electron. In this case, metals are losing electrons, so they are forming ions. And because they're losing electrons, they're going to form positive ions. When metals react, they always react with non-metals. They don't react with each other. They only react with metals. React with non-metals. Remember, metals, they're trying to lose electrons, so they need something. Oh, it's frozen. Metals react with non-metals. They're trying to lose electrons, so they need something that's going to gain their electrons from them. And because non-metals gain electrons, metals will react with them. And when they do react with them, they form ionic compounds. A metal and a non-metal react together to form an ionic compound. So if we look at an example of that, I've got iron, which is a metal. I've got oxygen, which is a non-metal. I react them together and they form an ionic compound called iron oxide. Iron, the pure metal, has very different properties from iron oxide. Iron oxide, which is iron combined with oxygen, is the chemical name of rust, which is like a brown flaky powder. And then iron is obviously a metal. So as soon as they react, they form compounds with very, very different properties. Metals are very, very useful. They can be used to build lots of things, but unfortunately a lot of their compounds are not useful at all. So you're not going to use rust to build a bridge, but you can use iron to build a bridge. So the whole point of the topics that we've been doing recently is how you're going to get the iron back from the iron oxide. Not just iron, any metal. Once it's reacted and formed an ionic compound, how are you going to get the metal back from the ionic compound? Because the metals have lots and lots of different uses. And when we're talking about getting the metal back, we are talking about extracting the metal. So you're just getting the metal back. You are extracting the metal. And there are a number of different ways that you can do this. And we need to look at the different ways and which method you are going to choose. So we've seen this on pretty much all of our slides recently. It's the reactivity series of metals, and it puts the metals in order of reactivity. You've got potassium at the top, you've got sodium, lithium. Now, typically, we're going to do some exam questions in a minute as well, and you're going to see that typically you don't need to know this. They will give this to you on the exam paper when they want you to use it. So you don't need to know this list off by heart. So that one there is very important. Carbon is not a metal, but we do include it in the list, and we're going to see why in a second. And then we've got iron and zinc and hydrogen. We put hydrogen in, and we have copper, and we've got silver, and we've got gold at the bottom. I said all metals were reactive. That's not true, actually. Silver and gold, very, very unreactive. So if you went digging in the Earth's crust, you might be fortunate enough to find pure silver and gold. Because they are unreactive, they're not going to form compounds, and they will exist as the pure metals. But all of the rest of these metals, they are going to react, they are going to form compounds. Most reactive, as at the top, potassium, and they get less reactive as you go down the group. When you're trying to figure out which method you're going to use to extract, you need to consider this list. Okay, I've got carbon highlighted here. The reason I've got carbon highlighted is because it's not actually a metal, yet it's included in the list of metals. Okay, the reason why is because it helps us decide which method we're going to use. Every metal above carbon, the method of extraction you're going to use will be electrolysis. Every metal below carbon, the method you are going to use is called reduction with carbon. This can be described as well as just heating with carbon, but I'm going to call it reduction with carbon. But you can also just be heating with carbon or heating with coal. Carbon is just coal in its simplest form. So heating with carbon or heating with coal. This video is getting a little bit long. I'm going to move to another video. I'm going to briefly talk through electrolysis and reduction with carbon, and also the two biological methods that you can also use. So the next video will continue on with this content.